Thermodynamics is also important part in interview for interview perspective now, to knowing about thermodynamic questions and all.
Yes, yes, yes. Because main topics are boilers, then refrigeration theory, AC refrigeration theory,
Hmm.
basic gas laws, and
Hmm.
uh, heat pump, heat engine might be asked.
Okay, so let's start with basic gas laws. Basic gas laws is that gas laws, no? That is ideal gas law, Avogadro, first
Yeah, Charles
uh,
law, Gay-Lussac's law, Avogadro's law, and ideal gas law.
okay. I wanna explain this. That is first is Avogadro law. In Avogadro law, pressure and temperature is constant, and hence volume is directly proportional to number of moles. Correct? I made a trick to remember
Yeah.
this. Then after Boyle's law, in Boyle's law, temperature is constant, then and hence pressure is inversely proportional to volume, like P1 V1 equal to P2
Yes.
V2. And third is Gay-Lussac law. In Gay-Lussac law, volume is constant, then pressure according to that equation. What is that equation called? Ideal gas equation. Ideal gas equation. Uh,
I don't
uh,
think it's according to ideal gas equation.
it
Is it
made
according
up
to
of,
ideal gas equation?
no, according to no.
Yeah, I
It
think
will made
ideal gas equation is
all the
formed
law.
based on these
Yeah,
three laws.
yeah.
Yeah,
Ideal
four laws actually. On
for
the
law.
four laws.
So in Gay-Lussac law, volume is constant, then pressure is directly proportional to temperature. Okay, it comes out to be pressure is directly
Yes.
proportional to temperature. Uh, Now
Charles
Charles
law is
law.
there.
In Charles law, pressure is constant, volume is directly proportional to temperature. Correct. Uh,
Yes. Yes. And
Now
ideal
the
gas law is just Q is equal to
and
M.
yeah, and now the last one is Boyle's law. Na? Boyle's law, I already did it.
No,
Na?
you Boyles law, Charles law, Gay-Lussac's law, Avogadro's law, and ideal gas law. You haven't talked about ideal gas law.
These laws made an
PV is
ideal
equal
gas
to
equation.
NRT.
Yeah, PV equal to
Actually, I
nRT.
don't remember. Yeah,
And
oh,
now will
in
come.
exactly in which whether it was in Viva or some interview, I don't remember. They asked me about these laws, and actually I remembered PV is inverse proportional to pressure is inverse proportional to volume and all that thing. Formulas I remembered that. It
Mm.
just I said Charles law as Boyle's law and Boyle's law as Charles law.
I made a trick. That trick is
Got
called,
confused in that part.
yeah. I made a trick. It's one liner. आप तो गांव में कॉपी बांटो. It's आप तो means आप means A means Avogadro, or in आप P means pressure constant. I will share you the and in copy.
Okay,
In the copy is code word in which the first letter is the scientist name Charles, and the second letter
Charles
is
law.
the second is P. Okay, P means pressure constant. In Charles
Uh,
law, pressure constant. आप तो गांव में कॉपी बांटो. बांटो in बांटो, B is Boyle's law, and T is temperature constant. Okay, these are the
temperature. And Gav is
uh,
Gale
Boyle's
and
law.
V
Volume
for
is
volume,
constant.
right? Yeah,
Yeah, yeah.
it's pretty good.
It's good now. I have learned
Yeah, yeah.
about mind memory master, in which they taught us to make a trick to increase our mind capacity by different method. And it's amazing. From the last from the last 6 7 years, from that only I am topping in everywhere, like on the memory basis. I learn something very fast, like it's not for normal mind.
That's good. That's good.
And that behind that is a trick, but people along with me in my companions understand it's my mind capacity. It's trick only. Okay,
Yeah, yeah.
now
Actually, I
we'll,
used to do these
yeah.
tricks in like 10, 12, until 10, 12. After that, I just like visualization. I started to do the visualization and skip the part where you have to remember stuff. So I usually just, because in engineering you write, you get that log tables and like all that stuff. So you don't really have to remember any values or like formulas.
Uh,
I skipped that part on in engineering. I used to do that till 12th. It's
and
really fun.
in engineering, like conventional machining, there are different types of machine and all. There different types of process and all. For that process, for that is it helped me. Uh, in future, if you meet, we have I have that notes, and I have while I used to teach students, I also teach them to how to remember this. I will also teach you. One of the friend who is
Yeah,
IITian,
yeah, sure.
he's still obliged to me for teaching him, like that only. uh,
Yeah, I'm looking forward to it.
okay. Now the second question is laws of thermodynamics. As we know, there is three laws.
Yes.
Okay, that is zeroth law, first law, and second law. Okay, I will go with zero law.
No, there are four laws.
uh, Zero first, second.
Yeah, let's just complete the three. I'll tell you the
Okay.
fourth one.
In zeroth law, if temperature of a container, if we suppose a container temperature A and it is equal to the temperature of container B, and temperature of B container is equal to temperature container of C, then it will the temperature container of A and the temperature container of C will be in equilibrium. Okay.
Yeah, yeah. Instead of containers, you can say like this. Uh, let's say a body A
Hmm.
and body B are in thermal equilibrium with body C individually.
Okay.
Then the body A and body B must be in thermal equilibrium with each other. Instead of
uh,
container, you can use the word body.
yeah,
It
correct,
sounds
correct.
more appealing.
Yeah, and the let me correct you. If body A is in thermal equilibrium with body B, and body B is in thermal equilibrium with body C, then we can say that the body A and body C is also in thermal
A
equilibrium.
and C are in the, yeah, you
Thermal.
can use that A B C in whatever order you want.
Okay.
I use like A is A C B
Mm,
C then A B. I use in that order.
okay.
So whatever, as long as you are able to explain it, doesn't matter.
Correct. Correct. Now the second first law is based on the conservation of energy. Okay. Um, what was first law? First law.
Energy cannot be created.
Energy cannot be created and cannot be destroyed. That is Q minus W equal to internal energy of the system. I am not able to remember the explanation. I know the basic idea of first
Actually,
law.
it's total energy is equal to internal energy plus work done. That is P delta V, PV. I have recorded in that. You said the same thing, just in other words, because PV is work done.
Oh, no, there is one formula, na, Q plus W, that is heat energy plus work done equal to internal energy of the system. Or let me share a screen and yeah.
Is this? Are you talking about this formula?
PB work. You are talking about work done formula.
Yeah, PV is work, S is internal energy, and Q is total energy.
Uh, can you see my screen?
Yes.
Okay. Search. First law of thermodynamics.
कितने टैब खोल के रखे हैं यार, कैसे चलता है तेरा लैपटॉप?
First law, it is like with the help of extra 240 GB SD card, that is, and what and RAM 4 GB extra RAM. It, yeah, that's not,
बट स्टिल हीट अप नहीं होता क्या?
no, I have fan cooler. What is called thermo.
अच्छा, हाँ,
And
कूलिंग फैन.
yeah, and from the last 10 20 days, 10 15 days, I haven't switched off my laptop. I just
Yeah, I do that as well.
First
Close the
law.
lid and just walk off.
Yeah.
Yeah, you see, go to the back page.
First law of thermodynamics. Yeah. This Boyles.
No, go to the back page.
Back page. Okay.
Just
Yeah.
where you just
First law.
See, here's the formula on the right side. Scroll down, scroll down,
Okay.
scroll up, scroll up, scroll
This
up,
is na
scroll up. Yeah, see, yeah, U plus.
Q minus
Yeah,
W.
it's that formula. Enough. Yes, yes. So yes, this formula.
Yeah. The change
So
in
I
internal
I
energy.
remember it as
Mm,
yes, is heat added to the system
mm.
minus work done by the system.
We need to remember it this time. Like
Yeah, whatever you have like
Mm,
have been practicing by
mm.
till now, just continue with it. I used to do this, that's why I'm just going with that formula.
That is the same problem, the same formula. Like
Yeah,
uh,
if
uh,
you see, it's the same formula
uh,
because what you said. Repeat your question.
uh, that is change in internal energy will be equal to the heat added to the system minus work done by the system. Like we have to be
Yeah,
we have also work done by system will be negative and work done on the system will be positive.
yes. So let's say, and what I said is total energy, that is Q is equal to change in internal energy plus work. And what is work? Work is PV. So
Total energy
that's
is
the
total.
equation I said.
You said total energy. Yeah, work done is correct. You said work
Heat
done.
added is what I meant. Heat added is total energy
Okay,
or heat exchanged. I should have said heat exchange, I think.
equal to work done. Work done equal to PB plus change in internal energy. Okay.
Yes.
And what about second law? There is two statement for first law or only one
Second law
statement?
talks about first law is one statement, and for second law there are two statements. First one is Kelvin plan, and the second one is Clausius. But if you just want to say it in one sentence, then you just can say heat will always flow from hot body to cold body, unless you are applying some external work to reverse the effect. You can just say this one statement also, and you also can mention like Kelvin Planck statement, which
Mm,
is it's impossible to
mm,
look at it's impossible to make heat engine to produce work output in a complete cycle while it's exchanging the heat only with bodies at a single fixed temperature. First statement, and the second one is Clausius statement is it's impossible to construct a device which is able to produce no effect other than transferring heat from cold body to hot body.
mm.
You got anything and whatever I said?
It's stop sharing.
No, it's still sharing.
How to stop sharing?
It just stuck, I think. Try to move your cursor.
Okay, okay. Stop share now. It's
Yeah,
like there were
yeah,
there
it's
were
stopped. It's stopped.
two statement recording second law. The first one is Kelvin Planck statement, and the second is Clausius statement. In
Yes.
Kelvin Planck statement, it is said that we cannot make a reservoir with only one source. Is it or no?
You cannot make a heat engine working with only one source,
Heat engine working with only one source.
right?
Mm. And what about Clausius statement? Forget about
Clausius
that.
statement basically
Mm.
says that you cannot make a machine which will be able to complete entire heat energy you are providing to produce only work.
It will
So some
like
of it
there
will
will
be
be
lost in the form of
yeah, correct. Now I
some
remember.
losses.
There will be some losses. We cannot produce 100% work done by providing 100% heat,
Yeah,
or
right.
there will be some losses.
Yes.
Sir,
But
did you?
if someone is asking me the second law, I'll just say the second statement, which is, I mean, the common statement, which is it will always flow from the hot body to cold body unless you are using some external work to reverse the effect.
Like the heat flow.
And
Mm.
if someone asks specifically about Kelvin Planck and Cauchy statement, then I just mentioned them both. Because I have seen this in on like many website, and I think in PKNAG also they have mentioned the second formula is common statement, and then they were talking about that second law and all that stuff, Cauchy statement and all that stuff.
And the third law is the entropy law, na? That the entropy of
Yes.
substance will always increase. What is that?
Actually, the third law says that entropy of substance will approach a constant value at 0 degree Kelvin, and the entropy of substance will always increase is the outcome of the second law. Actually, it's a little bit confusing.
That is all.
I just hope someone doesn't. Yeah, I just hope interviewer doesn't like talk about entropy, because it's very confusing to explain also and to understand also. So can you just explain the entropy? Just
entropy is the degree of randomness. Okay. When there will be natural process, there will be always increase in entropy. Like degree of freedom will increase. But there is a two exception. Like in case of boiling egg, which there should be decrease in entropy because liquid is converting in solid, and we know the liquid entropy is more than the solid entropy. Like their particles are more freedom, are having more freedom in liquid as compared to solid, correct? But in case of egg, when it boils, it becomes solid. There will be change in some structure. Okay, they made them some more arranged. Okay.
Also, you are providing heat. So
And
heat increases, entropy will also increase.
And the second one is when we stress rubber, na, their entropy decreases, because when we stress rubber, na, the molecules arrange themselves more in manner. Okay. And entropy is the degree of randomness, and I think is
Yeah, I think that's enough for the interview. But I've read it somewhere. I found it a little funny. So let's say you are just throwing a egg on a wall.
okay.
Okay. So what will happen? The egg will splatter, and it will just like bounce back at it. So if you just reverse that process, so the possibility of that splash egg will become whole again is very less. There is a possibility, but it's very less. So that's why entropy always increases. You can't say that entropy never decreases, but there is very less chances, which can be like negligible. Like some advanced level discussion with
Like
someone.
We can also mold
Researcher.
this question. We
So he
can
tried
also
to
yeah, that the all natural process are irreversible, what is that? It is
irreversible.
And in irreversible
Yeah,
process,
irreversible.
entropy will always increase.
Yes. Yes,
Correct.
right.
In because
Yes.
in yeah, I have very amazing notes.
As far as it's right.
What is heat engine?
And whenever I just
Yeah.
yeah, heat engine is a device which is used to which works between atmosphere and the hot body basically.
And what is pump?
And heat. Okay, I just said the wrong thing. Heat engine uses the heat energy and converts it into the useful work, and pump removes the heat from the cold environment and provides it to the hotter environment by using some external provided heat.
A refrigerator is like what is the no, sir has told heat pump and refrigerator. In heat pump there is flow from sink to source. No, like there will be always flow from source to sink, like higher energy to lower
Yes,
energy.
yes, yes, right.
But
Yes, yes, yes.
in heat pump from with the help of external source, we reverse the process. Correct? That's why its coefficient of performance is always one,
Yes, yes.
greater than one. Sorry.
Uh, yeah. I have another question. It is, what's the difference between refrigerator and heat pump?
Okay. In let me first explain deduct refrigerator. In refrigerator, what we do, we extract heat, okay, from higher temperature body, okay. We extract heat from higher temperature body. Correct.
You are actually okay. Okay, just continue. Continue. We'll talk about that later. Okay, continue. Just start
Okay.
breaking your flow. Just continue with that.
uh like or in pump what we do is we flow heat in a higher, like in higher temperature region. We flow heat in higher temperature region. The same thing, I think, like in
Both are the same, right?
okay,
You want
yeah,
to say that?
yeah.
Do you want to say that both are the same?
Like in heater in a room is a example of heat pump, okay. What heater do?
No, no. Heater is different and heat pump is different. I think because heater is what is just converting electrical energy into your thermal energy, right? But what
But
heat
heat,
pump is doing, it's extracting heat from the environment and it's pumping it in your room.
yeah, correct. Now I remember. Extracting heat from the environment and inflecting in our
Yeah,
room. That our room is at higher temperature, and from what it should generally happen, it should happen that the heat should flow from our room to environment. But what heat pump is doing,
right.
it changing the source, like changing the direction. Okay.
Changing the flow. Yeah,
Uh,
with the direction. Right.
and in refrigerator, what refrigerator does, that the it extract heat and expel to the environment. It's the same process. Environment is at high temperature, and I am confused.
But
Hmm. Like
but
it's the same thing,
these
na?
heat pump and refrigerator are two different things. You agree that? Actually, I think
I am seeing the
no,
direction
but
is also same.
refrigerator and heat pump are two different things, but they are doing the same work. Yeah.
In heat
So
pump,
the
sink
main
is
difference is
atmosphere.
in
The,
refrigerator.
in heat pump, sink atmosphere is
Okay,
working
okay,
as a
hold on,
sink,
relax, relax,
and
relax.
in
Yeah,
refrigerator
yeah. And
atmosphere is
what's happening in the
refrigerator atmosphere is
it's
working as a
also same.
source, working as a source,
No, how
like in
refrigerator is rejecting heat to the atmosphere only, no?
hmm, yeah, atmosphere
Why can't
only
I say?
the,
If you
yeah,
see,
correct, so then
okay,
yeah,
okay,
okay,
okay. I'll just try to get rid of that confusion. See,
okay.
if you check the formula of COP for refrigerator, what is it?
Heat input upon work done,
Q1 upon W.
q by w, uh,
Q1
q1 upon w, desired
divided
output
by
upon
W,
work input, q by
right?
w, yeah.
And what's the COP formula for heat pump?
uh, w by q2, like work done upon
No, Q2
q2 is
by W.
the no,
Q2 by W, no?
q2 by w, no.
So in refrigerator, yes,
Yeah.
Q2 by W.
Okay. Sir, why is please sir something has taught wrong also. Like Prince sir has only I am opening Dreamer package. Let's say Q2 by W. Yeah, Q1 by W and Q2 by
Let me
W.
just.
Heat
Yeah, I'm
in
right. No? Yeah, it's right.
what?
It's right. No, you confirmed it. The formula posted in the chat box. It's right.
Okay, okay. Let's suppose to be right. Yeah, explain. You explain it. No.
Okay. So in the refrigerator, your so what's the formula of what is COP? Output effect upon the input energy, right?
Okay.
In rough terms.
Mm,
Okay. So in the refrigerator, as the output, or you can say your target is to cool a body,
mm.
and the heat pump, your target is to heat a body.
Correct, correct, correct. Now I'm
Getting
getting
it?
it. Yeah.
That's the one difference. And in other words, you can just say that refrigerator works between cold body and the environment,
Mm,
and heat pump is working between hot body and the environment.
correct.
I think the first one is more like
Mm,
got and convincing for the.
mm,
It seems like
mm.
they have drawn the conclusion rather than just we mugged it up from any source. Is
Yeah.
that right? I mean, the
Correct,
first
correct,
thing I
correct.
said, it's
Yeah.
working output,
Uh,
right?
right, right.
I think this question has been asked before. Difference between
So
heat
heat
pump and
pump. So heat pump work between hot body and environment and cold body and gas. So that's why there is Q1 and there is Q2, because what we are doing,
yes,
we are extracting heat from atmosphere and providing to in our room. Okay,
yes,
in a case of heat
to
pump.
heat
Okay,
our room.
to heat a room.
Yes,
So heating room, that is Q2 by Q2 is the desired effect, and desired effect upon work input.
yes,
And in case of refrigerator, we are extracting heat from food, that is Q1, and
cold body.
from cold body, that is Q1, and transferring it to the source, that is atmosphere.
Yes,
Okay.
yes,
Yeah, maybe Kiran, missing Kiran and
yes.
all to explain this better. And the basics of
Yeah, yeah.
basics
Yes, yes,
of
yes.
basics of refrigeration cycle is what?
I mean, apart
Compressor.
from the COP formula, no,
Mm,
whatever I said about the target, that's the right thing.
mm.
Okay, you can use that. It just we have to
No,
check
no,
the formula,
I have
but I'm
also
sure
checking
it's
up.
Q2 upon W
Yeah,
and
you
Q1.
correct, correct, correct. I have just here checked it. Okay,
It's it's correct, no? Yeah,
it's
okay.
correct. It's damn correct.
Okay.
You see, time is we are having only 5 minutes. Okay, let's complete then. Now the
What's the
second
other
question.
thing?
Mm. Basic refrigeration cycle. That is cycle is VCR cycle consists of
Yeah, we have
compressor.
been discussing it a lot of times. Yeah,
Yeah,
just
we
in
should
that.
have. Okay. Basic cycle efficiency different process. Adiabatic isothermal we have already discussed. We know in adiabatic Q equal to 0, no heat enters on
It's
leak. Types of
yes,
boiler we have.
isothermal is no change in temperature.
AC
Then
and
there is
refrigeration
isoboric where no change
volume
in
is
pressure. Volume.
so volume is
Wait, wait.
constant.
Yeah, and isentropic, entropy constant, isenthalpic, enthalpy constant,
Mm.
and what? Okay. Can you explain the throttling process?
Throttling process is isenthalpic process. It is a reversible process. The sudden it is a
It is
irreversible
reversible or
isenthalpic
irreversible?
irreversible process, has it will it is shown by dotted line. And throttling process is an isenthalpic process. In process, enthalpy will be constant, means total there will be no loss of heat energy. Okay, there
Heat.
will be
Yeah.
change of state, like in
Change of temperature can be there.
temperature, uh, if heat is constant, that is, no, delta H will be constant, na, heat enthalpy. What is the difference between heat and heat enthalpy?
Yes. Heat and enthalpy are basically same thing.
Okay. How
I
it's
think
come, only 3 minutes are remaining. I think we are
I don't know.
okay. Uh,
I,
okay,
I don't know. Let's just try to make most of it.
okay. You know about
So,
enthalpy
I
diagram?
mean, can you just explain that? No, no. Can you just explain the uh, what is it? Throttling process in terms of like PV, TH, TS in that terms? Because I'm
PV,
just getting a little bit
yeah,
confused.
okay. In throttling process, pressure is decreased and volume is increased.
Okay.
Okay, so we can make
Okay.
like decreasing pressure and increasing volume. Okay, that is by dotted line, not a linear one. Okay, correct. And
Okay.
in T and H, what pH, in
What's
pH,
happening about the temperature?
temperature is also reducing. Do you remember that
And
3D chart
what
of what about pressure is also reducing, volume is increasing, temperature.
temperature? Yes. And what's the reason behind reduction of temperature? Because
Yeah,
there is no, as we are saying, there is no heat is being exchanged, right?
yeah,
This particular question is kind of bugging me, and I'm not able to clear that out.
yeah. Now
Because if there is change in temperature, then there should be like some heat should be absorbed or released.
and temperature related to heat and now it's bugging me.
Yeah, I
It-
just transferred the data to you.
okay. No. In entropy, that some temperature change. Let me search in entropy. In entropy, that some temperature change can change.
Yeah. And on that note, actually, in VCRS, condenser is actually cooling the refrigerant.
Yeah, yeah. By rejecting heat to the atmosphere at constant pressure.
Yeah, because in condenser we are getting, and why do we get that flat line in TS diagram? Because that's latent heat of evaporation
Yeah,
or
correct.
condensation.
See, I have just said in throttling process temperature doesn't change. It was my fault. Now I am correcting it. Since temperature related to the heat enthalpy is a function of temperature. Just you said now, if temperature is changing, how is the internal energy? How is the heat enthalpy is constant? It does not change temperature. It's only change pressure. It only like low increasing volume, lowering of pressures, and in lowering of pressure, maybe that's why it becoming chilled by lowering. We something we can cool down by lowering pressure also, na.